Alrighty. The first example is they transform a polar equation and then we graph it in Cartesian. So let's go ahead and do that. So similar to what we did last time, we transform the polar equation in rectangular coordinates. Then identify and graph the equation. So the first couple of questions in your homework will look something like this. You say theta is equal to 5 pi over 4. So you're going to take the tangent of both sides, and that'll help you convert it into a rectangular form. So take tangent theta, tangent both sides, 5 pi 4. So tangent of theta would be equal to 5 pi 4 should be a 1, right?
It's on your circle.
And then remember, tangent is defined as y over x. So this would be really y over x equal to 1.
So we'll solve for y.
And we get y equal to x.
So this line is the same as this polar equation.
So honestly, it's just a y equal x line, right? Straight through the 45-degree angle area. Oops, missed the center, but whatever. There we go.
So in the homework they'll ask you what is the transformation for this, and then you'll give them this part.
This is the first, like, part A, I guess.
Then part B will be just plotting it.
And I don't mind if you use your graphing calculator or if you use what's it called? Yeah, the Desmos thing. Are there any questions on this first one?
I had a question on the Desmos. So on the first test that you let us use it, like, how do we even open it up if we're doing lockdown browser?
So you weren't able to do it?
I wasn't, at least.
Okay, well, I guess on this one it might matter, so I'll have to figure that out. The last test, I don't think you needed it much, but I'll get back to you on that one. I don't know. One second. Yeah, I'll fix that as soon as possible because I really want you to use it, but I know a few students emailed me saying they weren't able to figure it out on one of the exams. Yeah,
I'll let you know. All right, so transform the polar equation to an equation in rectangular form. So it's really the same question. We'll just do a harder one. Then identify and graph.
All right. So here's the polar equation. R is equal to 6 cosine theta. So let me pull up some notes so you can see what's going on. 10.2. Where did that go? Yeah.
Okay, so it should be one of these guys. Let me see where it starts. We kind of mentioned this before. R equal to 3 was a circle of radius 3, right? But when you have theta equal to an angle, that will be a straight line, which is what we did just now. But the R cosine theta equal to some number is going to be a horizontal line. R sine is going to be, vertical. R sine would be the horizontal. So just, and I'll send these book notes to you after class. I don't think I've sent chapter 10 just yet, but just remember R cosine is related to X. So X would be equal to some value, right? Which is always a vertical line, which we've talked about before. So let's convert this guy into X. So we know that X is equal to R cosine. So and we know that R squared is equal to X squared plus Y squared. So currently we don't have an R cosine, right? But we could multiply both sides by R and force it to have a R here. That way we can convert it. So I'm going to do is multiply both sides by R. And I'm going to go ahead and put the R right in front of the cosine. So now this guy is X. So we have R squared equal to 6R cosine theta, which is really X squared plus Y squared is equal to 6X. Does that make sense so far? Or is that clear? All right, but since we have an R and not an X value, it's not going to be a straight line. We can already tell this is going to be like a circle. So we're going to have to complete the square for the X values and see what we can do. Okay, so get all of the X values together. We'll leave a blank spot for the X stuff. That way we can complete the square. Oops, if I subtract 6X, that should be minus, right? Okay, there we go. So then take half of B and square it and add it to both sides, right? That's how we complete the square. We've done this a few times, so I'm hoping you remember. So AX squared plus BX plus C. B is equal to -6. And we're going to add B over 2 squared to both sides. So that would be the -6 over 2 squared, which is a 9, right? Half of 6 is 3. Squared is 9. So I'm going to add 9 to both sides, which will then let me factor this into x minus 3 squared plus y squared is equal to 9.
Is there any question on the completing the square? I mean, I know I skipped some steps, but if you forgot how to do this, let me know. If not, I'll move on.
Yeah, I don't really remember how to do it. Like I see what you did, and it's simple enough, but is it always like that?
Yeah, it's always going to be that way. Here, let me just grab a random polynomial so you see what I'm talking about. Yeah, here, we'll come back to this just for fun, right? So let's say we just made up a number, x squared plus 2x plus 7. This does not factor perfectly, right? We'll call this some function. So what you do is you write down what b is, and then you take half of b. It's going to be 1, right? Or 2 over 2, and then you square that. So it's always going to be this way. So that's the magic number I need to add to complete this square. So back in, I don't know, I think we revisit this in college algebra, but we first see it maybe whenever you first see parabolas or circles. So what you do is you leave a space and you move that 7 over. You just ignore the 7 and you add that special number. But if I only have one side, I need to subtract. Add and subtract to keep the balance. So then this guy factors perfectly into a perfect square, which would be x plus 1 squared, and then this guy becomes a 6. So it's always going to be this way. You just look at whatever the heck the b term is, you take half of it, and then you add, and then you square it and add to both sides. But if you do not have both sides, then you must add and subtract. But in our question, we do have two sides, thankfully. So half of 6 is 3, squared is 9, and you just add it to both sides. So then this guy.
The reason is just to get like 1x.
What's up?
Like, is it the reason we're doing this is to get 1x in the equation, just so it looks prettier, or like why
The reasoning is so you can see where the center of the circle is. Like if you don't do this, then it's really difficult to graph by hand. If you don't graph by hand, then this part may not be necessary. But once it's in this form, you can see that the center of the circle, because remember the general form of the circle, right? Is x minus h squared plus y minus k squared equal to r squared. So the center is hk, and then r would be 3. So if we graphed it, let's go ahead and graph it real quick. Then you can see why it's helpful. Okay, so x minus 3 squared, oops, plus y minus, oh, actually, this is just y, my bad, equal to 9. All right, so.
Minus 3, isn't it?
I'm sorry?
X minus 3, isn't it? Minus 3.
Oh, yes, thank you. There we go. So now because it's in this form, you can see that the center of this circle, let me go ahead and plot it, right? It's going to be 3, 0. You see that? So we know this is the center because it's been put in this general circle form. But to do that, you have to complete the square for the x, and sometimes you need to do completing the square for the y at the same time. Does that make sense? And then the radius is there now, right? The radius will be 3, so it'll be 1, 1, 2, 3, yeah. This is going to be 3. The center is 3, 0, so distance of 3 to all directions for a radius. But if you did not complete the circle and you used a grapher, like you're technically, let's say I said, you know what, I'm a lazy SOB and I'm just gonna plug it in here. It's all good, who cares? Would I get the same thing? And yeah, right, the green circle is the same. So the purpose of doing this on paper is to be able to graph it by hand. And if they ask you questions like, what is the center and what is the radius, you are now able to answer those questions a lot easier without a visual. Is there any other questions on Coder 2? All right, let's go to the next one. Number 3. So on an exam, the main thing I want to see is, can you transform it? The graphing part would be great, but it's not a huge deal. If you use your graphing calculator or something else, that's fine. But I want to see the conversion. So transform the polar equation to an equation in rectangular coordinates. Then identify the graph. I guess I have not been identifying it. So let's go back a little bit. On the first one, number 1, right? You would say, yeah, that's just a line graph, right? Oops, I got all blurry there. Second one, you say, well, I didn't graph it on here, but we do know this is a circle of radius 3, centered at 3, 0. So on this one, you'll do the same work, convert it, and then decide, okay, what kind of graph is it? Excuse me. So R would be equal to -2 sine theta. I'm gonna write my formulas here so I don't forget. And I know that R sine theta is equal to Y. So the question they gave us is this. So we're gonna do something similar. We're gonna multiply R on both sides. That way I can convert to Y. And once I have an R squared, I'll do the same thing. So multiply both sides by R.
Could you substitute the -2 sine theta into the y equals on the right for R?
Here?
Yes. So you already have R equals, so couldn't you substitute it in for R and do -2 sine theta sine theta? equals y?
You could, but the point is to get rid of all the trig stuff.
Oh, okay.
So if you, I mean, you're not wrong. Mathematically, you can sub whatever you like, but don't forget what we want to do is have complete conversion from polar to x and y.
Okay.
So whatever gets that done is what you want to do.
Okay.
So right here, we'll end up with this, right? So then this can be replaced, and this will be your x squared plus y squared. Okay. So we have x squared plus y squared equal to negative 2y, right? So now we're going to do the same thing as before, but we're going to complete the square for the y terms, because x squared is already technically a perfect square. There's no terms we need to worry about. So I'm going to move over the y and set it to 0. Then I will complete the square for the y terms. So what is the value I need to add in order to complete the square?
One.
1.
Yeah, it's going to be 1, right? Because half of b, right? So let's just do our little side work here. B is 2. B over 2 is 1. B over 2 squared is 1 squared. So I'm going to add 1 to both sides. So now this will be perfect square, which means you can factor it into this. That's all that means. So once it's in this form, right, we know the center. What's the center of the circle?
0, negative 1.
Yeah. And radius?
0.5. Net half of 1. Or is it
Square root
1?
of 1.
Oh, okay, so 1.
Yeah, just 1. So the question asked for us to transform it, which we did, and then identify the graph. So it is a circle, has 0, negative 1. So where's negative 1 right here? That's the center, and it goes out at most 1 in every direction.
It's y is negative 1, not x.
Ah, shit, you're right. Shoot. Thank you. There we go. So 0, negative 1 is down here. Go out in every direction. See my little crappy circle here. There we go. Looks like an egg, but I promise you that it is a circle. Do you have any questions on number 3? Okay. Let's move on to number 4. Number 4 and 5 is when they start asking you about different types of graphs. Here, let me find them. One second.
There we go. So we're going to have, we just talked about the circles. Now let's look at the cardioids. So depending on A, so if you have some value plus cosine, some constant, or plus sine, you're going to have a cardioid. Basically, it's kind of like a circle, but it's like more of a heart. Right here, kind of sinks in depending on your function. So if A is positive, it passes through the pole. Let's see if I can find a better one. So here we go. Yeah, so they ask you if it's a cardioid or not, or if it's a limison, just a French word for this type of graph here. So it has an inner loop. It doesn't just cave in, it goes all the way in here. And that depends on the A and B. So let's do an example of those. Okay. But like I said, on these questions, I'm not going to force you to graph it by hand. So all I really want to see is, can you tell me if what type of graph it is? So just graph it on your calculator. Let me grab a calculator so you can see. If you have a graphing calculator, you'd have to switch to polar. So you would have to go to mode. Here it is, where it says function, parametric, and polar. Select polar under mode. Yours may be different, but it should be in mode towards the bottom. Once you've converted, you'll see it says R instead of Y equals. So the next question says, identify and graph the polar equation. Well, here it is. And I'll write it down in a second. Let me zoom out. Zoom trig. Nope. I pressed the wrong one. There it is. So it's going to be cardioid that passes through the pole because the A is greater than 0. So let me write down the question. Example 4. Identify and graph the polar equation. So R equal to 13 plus 13 cosine theta. If you factor the 13 out, that will be your A they're talking about in the book. So this shape, right, going back to the book here. So we have some number A that can be factored out. So A times 1 plus cosine is what we have right now. And A is positive, so it's going to be a cardioid that passes through the pole, meaning it caves in a bit, as we saw in the picture. Right? Let me find a better picture. Okay, R equals 13 times 1 plus cosine. There it is. Okay, so our A is 13, and we have that shape. Some number A times 1 plus cosine, which tells us it's a cardioid. So all you have to do is use your calculator or grapher and tell me what kind of graph it is. So you'd say it is a cardioid, and this is the general shape. If you were to do it by hand, you'd have to plug in values from the unit circle and then kind of estimate this, but it takes a bit, and it's not really worth it. It's not too bad though, but no, 1 second. I think I forgot to mention, when they mention the pole in the homework, they're talking about the origin. That's all. It's just when they're in polar, they say pole. That's the only difference, but it's the same thing. Okay. I think that might be about it here. Oh, this is a good one. Example 5. It's the same deal. Identify and graph the polar equation. R equal to 7 cosine 2 theta. And you better note here, cardioid where A is 13. Okay, let me show you the notes here. So this is a rose. So the number of petals is determined by the multiple on the theta. So if n is even, then you're going to have 2 times n petals. If n is odd, then you have n petals. So, for example, right, if it's going to be 2 theta, it should be 4 petals, because n is that number on the theta. On our example, we have 2 theta, so it's going to be 2 times 2. If it was 3 theta, then it would just be straight up 3 petals. Let's see here. Let's go ahead and graph it and see what it looks like. So this is the R equal to 7 cosine 2 theta. So whenever you see a double angle with no extra terms, it's going to be one of the rows types of graphs. So like we said, if n is even, then you multiply times that number by 2, and that's the number of petals. So if this was 4, then we would have 8, right? If you have 6, then we should have 12. But if you have an odd number, then it's just exactly that number. If it's 3, you have 3. If you have 5, you have 5. It doesn't multiply when it's odd, only when it's even. Does that make sense? So the question may ask like how many petals or what type of rows, and as long as you graph it, that's all you need to do. So in this question, I would just simply say, just plug in 7 cosine 2 theta. If you do it on here, you should have your rows. You guys have any questions on 4 and 5? I mean, honestly, it's just graphing it and writing down what type of graph it is.
So on 5, we would say it's a 4-petal flower or something.
Yeah, you would just say, so it's a rose, and if they ask for the petals, you would say 4.
Okay.
They may not ask, but I do want you to remember, or at least write down that note for your notes. But I'll send that to you after the class.
Okay.
It's all in there, all the formulas and stuff. Okay, that's pretty much it for this section. There's not much to do. It's just really, can you convert back to X or back to polar, and then can you tell me what kind of graph it is? That's all there is to it. Okay, I think I'll save this next one for next time. This one's a little more complicated. Start reading a little bit just to help you out. So read up on 10.3, De Moivre's theorem. So we got to revisit the complex plane, which is the imaginary numbers. Let me write that better. Okay. Let me make sure, let's check our schedule real quick before we stop. I think we're good though. You guys have any issues with the exam before we start heading out?
One of the questions, every time I calculated it, the numbers were like slightly off.
I mean, as long as you wrote it down, I mean,
Okay.
I'll accept. I mean, if it's off by a few decimals, I'm not going to care.
Yeah, it didn't match, so I selected no triangle, and it was wrong.
I mean, if it's on your paper and you showed your work, I'm not going to care about the multiple choice.
Okay.
That's what matters. Okay, let's see here. Schedule. Yeah, I guess we are on schedule right now. So next week we'll go over De Moivre's theorem, get into vectors and the dot product, which is going to be very helpful for physics if you end up taking that, or linear algebra. If you never take that, then you'll never see it again, which is fine too, I guess. But it's helpful in technically computer science too. because a vector is really just an array. Let's see, where is it? Let me share my screen here. So,
Yeah. During the summer, for one of my research, we had to calculate that, and I didn't know what I was doing. And I
doing
said
what? I'm
no.
sorry.
Using vectors, he had us use the vectors to find the inner pockets of some proteins, and I
Mhm.
still don't know what I was doing.
Oh, it's okay. I mean, maybe going through the basics will help. So we'll talk
Yeah.
about like the definition of a vector, and we'll go through like the dot product, the cross product, and I think that may help. If not, you may need a little bit of linear algebra. That usually helps.
Okay.
But yeah, feel free to show me that. It sounds interesting. I'm curious what that was.
Oh yeah, I'll definitely send it to you because I'm still working on it and still don't know what I'm doing.
Yeah, I'll check it out. I mean, I have some. We'll probably have some free time this week.
Okay, cool. Thanks.
I guess. Do you have any other questions before we call it a night?